Hello everyone. Today we will discuss Spark library in Python. See, Spark libraries are libraries which is in inbuilt function of Python, and we use it in programming of machine learning algorithm, machine learning models, and AI programming. So let's discuss it. So before moving to our first topic, these are the learning objectives of a Spark library. Number one is introduction to Apache Spark. From where this Spark came from, what is the application of a Spark, and what are the background features of a Spark library. Then there is why Python, or we can say PySpark instead of a Scala, because Scala is the programming language which is used to create Spark libraries. Then there is resilient data distribution dataset of a Spark. Then SQL and data frames of a Spark library. Then Spark streaming in Spark, where like graph streaming, machine learning, and other features of streamings in Spark library. Then graphical interface of Spark, which is known as Graphx. Then Spark machine learning, which is machine learning modeling. Then AI programming and other things. After that, we will move to our end of the topic, which is practical relevance of Spark, and what are the applications of Spark in Python and AI programming. So first topic is introduction to Apache Spark. Now, what is Spark basically? Spark is basically a fast and general engine for large scale data processing, top level Apache project since 2014. Basically, Apache is a, we can say, is a company which has created many software, many notepads, and we can say many kind of programming language servers, and Apache Tomcat, Apache MapReduce, Hadoop is also given by Apache. So there are many things which is given by Apache. Spark is one of them basically. So Spark is given by Apache in 2014, and it was given because of the response to limitations in the MapReduce. See, Apache MapReduce has some limitations, and it cannot run program it if the big data set is very much fast or very much resilient. In that case, we use Apache Spark instead of Hadoop MapReduce in memories, which runs 100 times faster than Hadoop MapReduce and 10 times faster on the disk. So basically, it is implemented in a Scala programming language which supports Java, Python, R, runs on Hadoop, Mesos, Kubernetes, and standalone clouds. So these are the features and the introductory features of Spark, and these are the reasons why we are using a Spark library instead of Scala and MapReduce nowadays, because it is much more useful than we can say Python. It is much more useful in Python than Scala and other libraries. So this is why Python has implemented Spark library in its background. So these are the points. Number one is a fast and general engine for large scale data processing. Now, we have already discussed big data. So large scale data processing comes under the big data, where we can process the large data set, the big data set. Like if we are processing the data produced by Facebook or Instagram, or the data which is produced by Amazon, so we cannot produce these kind of data in using the small library functions like SQL and other. So SQL, PostgreSQL, SQL, Kafka, and MongoDB, these all features, these all SQL libraries are we can say combined itself, and then Spark library has been created so that it can run all these SQL datasets or SQL functionalities in it. So this is why Spark libraries came in existence, because these datasets cannot handle the large scale data processing, and this is why Python has introduced Spark in its library function, and it has inbuilt it has came as an inbuilt function in Python. So it is a top level Apache project since 2014. It is created in 2014 basically. So what are the why people and why developers, or we can say data processors, data engineers, use Spark instead of Python, instead of MySQL, instead of Hadoop database or Hadoop MapReduce. So this was used when Hadoop MapReduce has got some limitations in the large data set or in large scale data processing. So in that case, response to limitations in the MapReduce run programs up to 100 times faster than Hadoop MapReduce. So basically, Hadoop MapReduce cannot run much more faster if we are implementing it in computer memory, in we can say inbuilt memory of a device. In that case, we are using Apache Spark, which has its own cloud memory where data is stored and data is recorded, data is taken as a record, and then in that case, if the data is stored in Apache Spark, in that case it runs much more faster than the Hadoop MapReduce, which was running the data in device's memory. So that's why Hadoop MapReduce can't run the data, and which is why people started to use Hadoop Apache Spark instead of Hadoop MapReduce, which is 10 times faster on the disk. Now, in what language Hadoop Spark is basically implemented? So Spark is implemented in Scala programming language. Scala is like we can say Java and other programming languages. So it is also a programming language. So Spark is implemented in Scala programming language, and it supports other programming language, which is Java, Scala itself, Python, R programming. It runs on Hadoop database, Mesos, and other data servers like Kubernetes and cloud. So these are the features, these are the introductory features of Spark, which is why people prefer, data engineers or data scientists prefer Spark over the Python and Scala. Now how we can download and run Spark on our PC? So Spark we can download Spark feature from this website, which is http://sparkapache.org downloads.html. It is a kind of site, and here we can choose type what is the version of Spark which we want to download, for 64-bit, 32-bit version, or the one which is we can download the newest version of Spark. Then we can choose the package type. What kind of package is basically we want. It is pre-built for Apache, Hadoop, or any other package. So these kind of package we want, any package that we want, we can download it from the website, and then there is file name created from which we can download Spark easily. Now Spark is downloaded as a zip file, or we can say .tar file, which is look like this. Now if you want to Spark, you basically use your Anaconda CMD, and here you will write this code pip install PySpark. In that case, it will automatically unzip this file, and then it will install the PySpark in your PC, in your system. So PySpark is the interface basically that gives access to Spark using the Python programming language. So what is PySpark? PySpark is working as an interface between user and the system, and it will give you an interface to access the database, the large database, and process it. So here is the interface of Spark. This is how it will look like. If you can use black screen, white screen, that doesn't matter. Then the Spark submit script in Spark's bin directory is used to launch applications on cluster Spark submit example1.py. So you can submit your script in Spark's bin directory, and the bin directory is used to launch applications on cluster. So we can use we will save the file, or we can save the script, our script in if any script which we are working in Spark, we can save it like example.1.py. So it is basically .py. .py is the extension of Python file. So this is how we will save our file in Spark's in a Spark directory, and this is and from where we will use to we can launch that application too. Now, why Python instead of Scala? So if someone knows Scala, he can use Scala because Scala is much more advanced than Python. But the learning curve of Python is comparatively easier. We can say Python is comparatively easier to learn than Scala. Scala has many complexities, many we can say it is difficult to learn from new programmers. Those are fresh to programming. So Python is easier to learn than Scala. That's why we can say Python is comparatively easier to learn, and Scala is much more complex than Python. Why we are using Python in Spark library? Because Spark is basically implemented in Scala. So people will ask this kind of question, then why we are using Python if it is implemented in Scala? It could easily recognize the commands if written in Scala instead of command which is written in Python. Now in that case you can answer it like Python is comparatively easier to learn for new programmers who are new to data, who are new and fresher to the data science field, and you can say it is easy to use. Python is easy to use than Scala because of its code readability, maintainability. Familiarity is far better with Python in Spark than Scala. That's why people prefer Python over Scala in Spark library. Now, if we talk about libraries, Python has got very enriched library instead of Scala. It has NumPy, Pandas, Matplot, and Scrappy, many kind of packages which is used in data analytics, statistics, and data visualization. That's why people prefer Python instead of Scala if they are using Apache Spark to process their large scale data set. If we talk about in terms of performance, so we can say Scala is faster than Python. No doubt Scala is faster than Python. But if your Python code just calls Spark libraries, the differences between Python and Scala will be minimal because they are much more similar to each other. They both are mixed paradigms language. That's why if we use Spark function, if we call a Spark package in Python, and if we call a Spark package in Scala, both of the packages will call the same Spark library, the same Spark function, and the difference between the difference in the performance in both of the languages or in both of the interfaces of languages will be so much small, then we can neglect it. One more thing is, any new feature which is added in Spark will be available in Scala first. So we have to check it online, because this is the drawback of Spark library, which is why people prefer Scala over Python. Because in if any kind of new feature is added in application interface of Spark, it will be available in Scala language first instead of Python. So here are the points. If you know Scala, then you can use Scala. The learning curve of Python is comparatively easier. It is easy to code because of its code readability, its maintainability, and familiarity is far better with Python. Now if we talk about libraries, Python comes with great libraries for data analysis and statistics. Also, it has very enriched library for data visualization like NumPy, Pandas, Matplot, Qplot. There are many more libraries in Python that are not available in Scala. Now, if we talk about performance, Scala is faster than Python. But if your Python code just calls Spark libraries, the difference in performance will be minimal. That means the difference will be so small that we can neglect the difference and we can use Python instead of Scala. Now, what is resilient distributed dataset? So before moving to that, we should know about what is distributed dataset. A distributed data set basically is a data set which is distributed to many devices, and they are connected to the same device, or we can say the same data set, which has the information of all the three devices. So if one device gets down due to any kind of catastrophe, any kind of uh, server down or system crash, then in that case we can recover the same data from the other system. And this is why distributed database came in market, because since the data is growing in exponential manner, we need to store the data in a hierarchical manner, in a distributed manner, so that we cannot lose the data which is much more important to us, instead of those data which are redundant and which is none of the use for the data engineers or data scientists. So what are RDDs? Resilient distributed data set. So RDDs are the core data structure in Spark. So every programming language has its data structure. Like C has its own data structure. These are like trees, graphs, arrays. So these are the data structure of C language. In a similar manner, Spark has its own data structure, that are called RDDs, which is resilient distributed data set. Distributed, resilient, and immutable. That means it can be stored unstructured and structured data. It can store both kind of data, and it can be easily evaluated, or we can say lazy evaluated. That's why Spark is built in such a manner so that it can create all kind of data, that is structured data. The structured data means the data which is in a form of index, in a form of table. Unstructured data, the data which is in the form of video, audio, or which has came from the interchange of process between two machines. So these kind of data are also can be these kind of data can also be used in Spark library, and it can be also evaluated. So these kind of evaluation is known as lazy evaluation. So distributed, resilient, and immutable data can store structured and unstructured way, and it can be evaluated lazy, which is known as lazy evaluated. So here is the data set of Spark. RDD the RDD is basically partitioned in many. Here are three partitions shown, but it can be partitioned in it has many part. It can be form of many part. It can be in form of many partitions. It could be n number of partitions in one RDD, so that we can distribute our data in n number of devices, so that we can't lose our data in the system. Now, how RDD transform and take actions. So here is the code. SC means Spark content. Then there is a text file star. If you know SQL, star is used for the particular keyword, or we can say the particular attribute or tuple which we want to evaluate, or which we want to retrieve from the table. Then there is map star. Then there is function filter star. Then there is reduce by key. That means we want to take our data, we want to reduce the table, and we want to reduce the redundant value from the table and collect those values which are important. So this is how RDD transforms and take actions in a data set. So here is first we will call RDD. Then there are tier 1, tier 2, tier 3, which is mapping of data, filtering of data, reducing of data, and then it will collect the data, which is known as action, and this action is known as lazy evaluation. Now, what are the transformations and actions in Spark, in Python, or we can say in Scala and in SQL? So here in Scala it is map, in Spark it is collect, filter is known as count, flat map is called the first function in SQL. The first function that we use in SQL to take the first query of the data from the table. Here the first query is called flat map. Then map partitions. Map partitions is used in Spark, and here in SQL we simply use the word take. Then there is reduce by key. Reduce by key is used as take sample. Union of data is known as take ordered. Intersection of data is called save as text file, and join is for each. So these are the words which is transformed in a, which is used for same job, but same job different words basically. So if we use map in Spark, that means count in SQL. If we use filter in Spark, that means collect. If we use flat map in Spark, that means we want to retrieve the first function of the dataset. If we want map partitions, that means we want to take some particular data. If we have applied reduce by key, that means we want to reduce the data by its key value, and we want the particular data that we want to that we want the particular data, and that data is retrieved by the table using this keyword, which is reduce by key. And in SQL, or we can say in Spark, it is used as take sample. In SQL it is union, here it is take order. In Spark it is intersection. In Scala it is save as text file. In Spark it is join function. In Scala it is for each function. So this is how we use the different word for same work in both the languages. Now how to create RDD in Spark? See, all the jobs in PySpark, or we can say in Apache Spark, is done by creating the resilient distributed data set in Spark. Since the RDD is the data structure in which Spark is designed or it is created, we have to create RDD in Spark. So first we have to reference a data set from an external storage. To call the dataset from external storage, we use the command rdd equal to sc.text file. It is like if we are using R programming, or if we are using Python, it is like read.csv. And in bracket we will use file.choose. If we use this code in Python or in R, if we are using data programming or data engineering, the pop-up will open, and where your file is installed, you can select that file, and you can use that file from external storage system to your program. So this is how we use we can reference a data set from an external storage to your program, to your system, to create a resilient distributed data set in PySpark. Now, parallelizing already existing collection. If there is already existing collection in PySpark, that is some inbuilt function, and we want to call it, and we want to parallelize it. So in that case, if like in Python we use import word, like import numpy as np, import scrappy as sc. So in PySpark it is like rdd equals to sc.parallelize to parallelize the package which is already existed in the collection of PySpark, and we want to call it to do its job and to import some database or retrieve some values from the given table. Now to create RDD from already existing RDDs, we will have to create another RDD, and we have to use map function. If we talk about the transformation words and actions, map is used to collect the data. So if we want to use RDD, and we have to create an RDD for the from an already existing RDD, we can just use RDD1, RDD2, which is new RDD we want to create, and another RDD which is RDD1 dot map. So here RDD1 is already existed in your background, or we can say in the library of PySpark. we want to call that RDD and we want to collect the particular data map, and in that case we will mention that values of the data set that we want to retrieve. So this is how we will create an RDD in a PySpark. First we will reference the data set from external storage. If the data set is already existed, then we will use parallelize function, and we will parallelize the already existed collection, and we will use it in RDD. And then after that we will create, if we want to create that RDD from an already existing RDD, we will just create a new RDD. We will have to just use the naming convention here. So RDD2 equals to RDD1.map. Here is the user.csv file which is given. It is basically a movie lens database, which is basically a database of movie crew members of particular movie. Here is the IDs 1 2 3 4 5 6 7 8. Then it is the age of the members of that crew which was working in the background of a movie. Their ages are like 24, 53, 23, 24, 33 and others. Then their gender, male, female, occupation, that is technician, others, writer, executive, administrator. So here are the zip files belongs to the particular occupation, particular position. So the total zip file, so the total entries of male and female are 670 and 273, which is given by the data set when we use our command like read.head, or if we use the command like head and then the file name. And here the CSV file which we want to execute. In that case, it will retrieve the head of particular data, which is the starting values 1 2 3 4 5 6 7 8 9 10. It will show these values in the head of that CSV file. Now here is the example. Use RDD to group data from CSV file. From PySpark, import Spark context. Here here it is the package PySpark. From that package we are importing Spark context, and here we import Spark context as SC. They have not mentioned here, so Spark context as SC. This is the language, and these are the coding conventions that one must follow. So first we will type from PySpark import Spark context as SC. Then we will use the other code, that is SC equals to Spark context dot get or create. Here we want to get the data from existing file, or we want to create a new RDD. Then print sc.text file, which is like read.csv command in Python, and here it is the file CSV file that user wants to retrieve from existing storage. Then map lambda x dot split. Here is the splitting value, and then it will given that how many splits it wants, 2, 1. That means it wants the values to split in two tables. Then we will use reduce by key lambda x, y, x plus y, and then we collect the particular value, and then we will stop the process. So after that process, the output which will come is 670 for male values in the data set, and female values in the data set are 273. Now Spark SQL and database. Spark SQL is Apache Spark's module for working with structured data. So here are the data frames of Spark, which is MLlib, which is used for machine learning, GraphLib, which is graph frames, which is used for graphical dataset user interfaces, and then there is structured streaming, which is used for basic datasets or basic databases. Then there is SQL, which is inbuilt feature of Spark. Then the data frames, data sets which they are using for which they have already installed some data frames and data sets in Sparks, like we can say in Spark, like in previous section we have taken Spark context. So these are the data sets which are already installed in Spark. Then there is a catalyst. So see, catalyst, if we all know about catalyst. Catalyst means the part of a program, a part of a reaction which increase the speed to react something, so that we can get output in a fast manner, or so that the speed of program will increase. And then the created RDD, we can create RDD after that, after the completion of that process. Now, what are the data frames and data sets in Spark? Data frame, the data frame and data sets are two different things in Spark. The data sets will be like untyped API and typed API. Untyped API equals to data frame equals to data set dot comma row, which is where rows and columns are two attributes in a given database, and there is aliases. Then typed API is only in the pre-installed data sets. So in Spark, the data frame is a distributed collection of structured data organized into named columns. So the data frame is basically a structured data which has already installed in Spark library, which is already given in Spark library, and which is organized and named into and organized into named columns. That means there are columns which is given and named in Spark, in the Spark library. So Spark datasets are statically typed, while Python is dynamically typed. So Python supports only the data frames in Spark, not datasets. We have to call dataset, or we have to install dataset from the external storage, from internet and from other devices. We cannot call the dataset in the pre-installed dataset like in R and in Scala. So this is the drawback of Spark if we are using Spark with Python. Now, how to use data frame to group data from CSV? So first we will call PySpark, then we will import Spark context as SC. Then from PySpark SQL we will import Spark session. Then SC equals to Spark context.get, where we will create our RDD or data set, and Spark equals to Spark session SC. Here we will call SC, or we can say the imported package, and then we will use the read function to read the CSV file, and then we will use separator to separate the values in a table in the given data frame. Then we will use .2df command, which is and the separator which has separated ID, age, gender, occupation, and zips. That means the number of zipped file for the particular value, for the particular attribute. Then how we are going to group it, or we can say how we are going to show it to the user. So here we will use group by command. Group by command is used to group the data as a gender, and then we will use count function to collect the data, and then show function to show the table to its user, and then we will use the last command, which is sc.stop, to stop the whole process. So this is how we will use the data frame to group data from the given CSV file. Now, what is the difference between data frame and the resilient distributed data set? So here is the difference which is given. Data frame is in SQL. Data frame can be in R. Data frame can be in Python. Data frame can be in Scala. Data frame can be executed in the all these languages. But if we talk about dataset could be implemented in only these two languages, which is Python and Scala. And dataset means the set of large database, the set of the large database set which is used by the user, and which we have to store in a cloud memory, or in a, we can say, which for that we need a very large memory. We cannot store the data in some hardcore memory, in a hard drive kind of memory. So we need memory like cloud storage, like Amazon Web Services and other. That's why RDD is basically a large data set, and data frames are also data set, but they are smaller than the RDD. So this is the basic difference between a data frame and RDD. So data frames are used in these languages: SQL, R, Python, Scala. All these languages are using data frames, but they cannot implement and they cannot execute the given RDD, because RDD is so large that it will take too much time to execute. The time complexity would be in an exponential manner in terms of SQL, R, and Python. But if we talk about Python and Scala, the RDD Python is an other field which is given by Python, where Python executes only and only RDD function, RDD datasets, and RDD Scala is already inbuilt function of Scala, which is used to implement resilient datasets, or we can say large datasets. Now, what are catalyst optimizer? See, we all know about catalyst. We have seen the in our previous code that we use catalyst. Here we use catalyst to increase the speed of our processing. Now, what are catalyst optimizer? Spark SQL uses catalyst optimizer to optimize query plans. See, optimization is, we can say, the optimization is used for to optimize the speed of program, the time complexity of the code, so that it will execute in some in, we can say, smaller time, or it will give it can be solved in a polynomial time. In that case, catalyst optimizer is used, which is used by Spark SQL to optimize queries of the given by the user. Now, it supports cost-based optimization since Spark 2.2. See, Spark has many versions. So since Spark 2.2 came, it supports cost-based optimization, not speed-based, or we can say in time. It is not talking in the terms of time complexity. It is talking in terms of cost of the program, that how much cost it will how much cost it will take to execute or we can say launch the particular data set as a data model to use in some machine learning algorithm. So these are the SQL, given data frames and given data sets. Then there is query plan. Then it will convert it to optimized query plan, and after that it will launched in an RDD, or we can say it will used, or it can be imported in resilient distributed data set to generate the given code. And after this process, the RDD gives an optimized an optimized data set, or we can say an optimized big data. Now, how will we convert an RDD to data frames? An RDD can be converted to data frame using create data frame or 2DF. See, create data frame or 2DF are the commands which is used by RDD to convert RDD into a data frame. That means a given data frame, and convert it to smaller data sets so that we can execute it and we can retrieve the value in easy manner. So RDD is equal. So here it is the code which is given. RDD equals to st.parallelize. Here are the values. Then our df, that means data frame, equals to rdd.toDF. The toDF is the command which is used to convert the data frame or the RDD to its given data frame. Then name, string, and age, which is given by integer. String and integer are the forms. Like we cannot mention anyone's name in an integer form. That's why name is given in a string form, that is character, and age is in integer form, like in SQL, varchar, integer, string. So this is like that only. And after that, df.show to show the output. We can access underlying RDD of a data frame using RDD property, that is df.rdd.collect, to collect the data from some particular data set, and so that we can convert the collected data into a small data frame. So here is the row and another row. So here we will collect that, we will call these two rows, and then we will use the given this code to execute this database, and this large database will be converted into smaller data frames in an RDD. Now here is an example how to create temporary view and data frames. So spark read.load users.csv, which is read.csv command to read the file. Then we will use toDF. toDF is a command to convert RDD to a data frame, and then toDF. In toDF we will pass the values like ID, age, gender, occupation, and then we will create or replace the temporary views, that is user views, and then we will execute the given data, the called data frame, and then we will use spark.sql to select count star, where star is used for particular value in SQL for the particular tuple in SQL language from users, where the table is users, and then we will use .show command to show the output in form of table. Then spark.sql select case when age is less than 25, or then negation of 25 when age is between 25 and 39, or in 25 to 40 when age is greater than or equal to 40. Then we will end up by we can say forming the table by ending we will end up forming the table in the categories, where we will first select the case where age is less than 25, then age is between 25 and 39, then age of the users, or we can say the crew members, is greater than or equal to 40, less than or equal to 40, and then there is 40 plus, and then we will count plus from users, that means count star, which is used for particular tuple from users table, which is group by, where we will pass the command group order by 1, and then .show command to show the output. Now how to read and write the data in Spark. To read and write the data in Spark, we will use df equals to spark.read.load users.csv, format equals to csv, where it is a separate, and separator equals to given line, and then .toDF to convert the RDD, and then passes the values from the table. Now this df.write.save as table users is known as Hive. As we all know, Hive is like beehive, where too many values are existed where too many bees are living in a single place. So Hive is basically a kind of thing where too many values of the data set of the database is stored in a single place. So all these values df.write.save as tables, where table name is users, is saved in Hive. Now df.write.save, where users.json format which is used format of JSON query, then we will create the mode override, if there is a previous pre-stored value of the same name with the same queries, or we can say the same tuples and attributes, then we will override that value so that the redundant value could be removed from the hive, and the only valuable tuples and attributes can be easily retrieved from the given RDD or from the given hive. Now Spark.sql select gender count star from JSON, where JSON equals to users.json, which is the table name, and group by gender. It is the SQL query which is used in Spark. Then we will use dot show command to show the data, and this is how we read and write the data in Spark library using SQL query language. And we will use Spark commands to save the table in Hive and JSON format to overwrite the previously stored data with same tuples and attributes. Now, what is Spark streaming? Spark streaming is basically scalable, high throughput, fault tolerant stream processing of live data streams. It supports file socket, Kafka, and Flume Kinesis kind of streaming softwares. Spark it receives live input data streams, and divides the data into data batches. So here is the process of Spark streaming. It is input data stream, then we will use Spark streaming, then batches of input data, then there is Spark engine, then there is batches of processed data. So the data stream, the data from given time 0 to 1, the data stream RDD at the time 2, RDD at the time 3, and RDD at the time 4, and so on. This is how the Spark streaming streams the data. Streaming means showing the data, showing the real-time process to the users. This is how streaming is done in Spark. After that comes discrete data streams. That is discrete data streams means SSC equals to streaming context, where we call the where we call the package in Spark. Then stream data equals to ssc.text file stream, where we use the file storage, the external storage, to call the file from our existing database. Then dot map, where we use the separator to separate the value, to separate the values in a table using some command symbol. Then stream data dot pprint to print the data using data in the data streaming. Then there is start, and then after, if the streaming is done, we will use the termination command to terminate the database. So here is the example of how the data is streamed. Here are the 5 values given, and then it uses the streaming command, data streaming command, which is shown in the previous slide, and then it streamed the whole data in the real time, which is time is given, where time is given, and then here's the data streamed to its user. Now, what is structure streaming? Stream processing engine built on the Spark SQL engine. It supports file and Kafka sources for production, socket and RAID sources for testing. So here are the data streams, and here are the unbounded table. So this is how data stream as an unbounded table works. And now after that, the new data in the data stream equals to new rows appended in an unbounded table. That means the new row is added to the table in the data set. Now here is the example of how to code structured streaming. That means stream data equals to spark.read stream. Here we will load the data in the format of CSV. Then the path is given tmp stream.csv. Then what kind of schema we are using, that is name string points, which is grouped by name, some if we are using, we want the summation of that, of the given data, we use sum, that, and then the points we want to sum, that means the values in the given table, and then order by sum points and ascending equals to 0. So here is the code: stream data dot write stream dot start equals to format equals to control and output mode equals to complete, and then await termination. That means we will wait for termination. After the process is done, it will terminate automatically. So here are the sum points of the structured streaming. That is the first value of C, E, and K, and this in the value in the second table, and then there are some points, that is 4 plus 4 equals to 8. Same goes with the other value, which is 5 plus 3, it is also 8. Then there is a third value 3, and here it is 1 in the second table, so some point will be 4, and then the fourth value in both of the table, which is 2. So this is how it will join two table, which is we can say union of two table is done by structure streaming. So it is joining the two tables, and if there is value which is not mentioned in the first table and it is mentioned in the second table, like this one, so it will taken as it is to the data set. Now comes graph frames, that is graphical data set or graphical property of the Spark library. So Graphx is new component in Spark for graphs and graph parallel computation. Here is the process. First it has called ID and property, which is vertex table and edges table, and it has shown the data in the form of graph. So we have the two tables are given, one is vertex, another is edge, and then it has shown the it has worked both the table on both of the table, and then it has given a graph to its user after processing both of the vertex and edges table. Here is the example of graph frames. Vertex equals to spark.create data frame, the values given to the graph frame. Then we will give another value for edges. It is the value for the vertex. Then then we will give the value for the edges. Spark create data frame, value 1 to 2 friend, 2 to 1 friend, 2 to 3 friend, and so on. And after that it will be a directed graph which will created by the graph frame of the Spark library. So here is the graph which is created by the graph frame of Spark, and these are the values which is used to create a graph. For 1 it is 4 to 2, for 3 it is 4 to 1, for 2 it is 4 to 1, and for 4 it is 4 to 0. So this is how graph is created using graph frames in Spark using RDD. So PySpark packages graph frames 0.05.0 is used to create a graph using graph frames in Spark, and these frames are used to create graph in the Spark library. And like the other packages, we have to import this package too, like import graph frames as GF, where G equals to gf.graphFrame vertex comma edges, where we will mention the vertex and edges in the code, and then g.shortest path, where it will show the shortest path for the given table. Then after that, alternating least squares, where it will show the least square values for the given table. It is that where we will define the parser ratings, v equals to x dot split, return int v0, int integer v1, and float v2, where integer, float are the types of the given values. Ratings equals to sc, that means Spark context text file ratings.dat, and then parser ratings, that means how to parse the given graph. So for the parsing of graph, we will use this alternating least square methods. After that, we will call the model, and then we will recommend for all users and then we will show the graph to its user. So this is the output for the movie sets given to the graph, where the title of the movie with its releasing date and releasing year. So this is how it will show the output for the given data set using the particular code using alternative least square method. Now, what is the practical relevance of using PySpark library? So basically, it provides a simple and comprehensive API. That means it gives the simpler interface than Scala, than Hadoop MapReduce and other, so that user can easily interact with it and user can access it in a easier manner than the other libraries of Python, or we can say other libraries of Scala. With Python, the readability of code is far better and maintenance and familiarity is much better than the Scala. So we can say we all know that Python is very much user-friendly language. So if we are using Python, the readability of code will be better. The maintenance of code will be much more better than the Scala, and we can be familiar to the language because Python is a high level language, so it is much more user-friendly than the other languages which we are using. So the third application is it provides various options for data visualization, which is difficult using Scala or Java. That means there are many options for data visualization, but the Python is better for it. So there are many options which is difficult using Scala and Java, but in Spark these options are much more useful and much more easier for if we are using Spark with Python than Spark with Java and Scala and other programming languages. Other one is, then there is Python comes with a wide range of libraries. There are many libraries used in Python like NumPy, Scrappy, scikit-learn, cborn, matplot, qplot, ggplot. So these all kind of libraries are used in Python to we can say to visualize the data. We can visualize the data. We can show the data in a scatter plot, in a form of scatter plot, box plot. So these all are possible because of the wide range of libraries used in Python, and because of the wide range of packages which are already installed in Python, and we can retrieve that packages from the GitHub repository easy. That's why Spark is much more useful with Python than Scala and Java. After that, the last but not least importance of Spark is it is backed up by huge and active community. See, many data engineers and many data scientists supports Spark because of its readability, its familiarity with Python, it is easy to use with Python, and it is easy to understand with Python. That is why many data engineers, many data scientists, many statisticians use Spark with Python, and they support it, and it is backed up by huge and active community of the data scientists and data engineers. So these are the practical relevance of Spark in Python. We have learned how we can use data set, how we can read and write our CSV file, how we can create the graph, how we can create the table, how we can retrieve the particular value using Spark, using SQL query language in Spark. So these all we have learned in this video. After that, thank you so much for watching this video. My name is Shivhari Tewari. I am pursuing MTech from Birla Institute of Technology, Mesra. So at last, thank you so much.